Hello friends, today we will see how to cross-compile file on a Eclipse for a Beaglebone. First of all, the we see the steps for the cross-compilation installation. You can see on screen sudo atp get update command. This is the required for the download package list from the online repositories. Second one is the this is the completion of the command, installation of completion of the command. Third one is the slide sudo atp get update upgrade. It is used for the fetches and install the newest packages version of any compiler or any installation process. Here you can see the completed command. After that, there is a sudo atp get dist upgrade. This is the command which is used for the intelligently handle changing dependencies with the new version of the packages. After the completion of command, you will see the screen like this. Then here is the one command. You can see sudo atp get install gcc arm linux greenup g++ arm linux. This command is useful for gnu c compiler for a arm 32-bit architecture. If we have 64-bit architecture, then this command as a arch64 gcc-arch64 is the command. We can change that like that command. After the completion of this command, we will get the result like this. Then we have the command like sudo atp get install default hyphen jdk. This is used for the Java runtime system required because IDE we are using Eclipse. This Eclipse is actually run on the Java environment, so we have to install first JDK. Here you see the completion of JDK. After that, we have to install GDB debugger. After the completion of GDB debugger, you will get the window like this. Then you have to install the make command that makes the project or build the system. This is actually there in the system, but if you install it, then it will not create a problem when you build the project. After installation of make command, you will get output like this. Then we will see how to install Eclipse. Here is the where we get the Eclipse software, where the www.eclipse.org. Uh, After searching this www.eclipse.org, you will get the window like this. At the top right corner, you will see the download button. You click on the download button, then you get the this window. After clicking on the download 64-bit, you will get the process of download. After that, you will see the window like this. You can change the mirror also, or by default mirror is also useful uh, as per your mind. Then you have to follow the following command for the completion of the eclipse. Once you downloaded the eclipse, then you have to change check cd download command. Then for the entire the file, you have to use tar zxvf eclipse hyphen inst hyphen linux 64 dot tar dot gz. This is useful for the entire the file. Entire file means like that unzip the file. Whenever you get any installer or any software, then you will get a unzip folder or unzip file. You have to zip folder or zip file, then you have to unzip that folder or unzip that file. So this is the useful for this enter the file. Then you have to get a eclipse installer. This command you have to run. After that dot slash eclipse hyphen inst, this command you have to go with that. Last command is launcher eclipse installer. After selecting that, you have to select the eclipse id for c++ development. Select the installation for the or keep it as at default. This process I will you show. After you get completion, you will get the eclipse cpp or eclipse like a folder on your desktop or your ubuntu window. Then here is the you shown the eclipse folder. Such folder is created on your file manager. Going to that eclipse folder, you have to see the eclipse or cpp 2020 folder. Inside the this cpp folder, you will get the eclipse. Then you will get the in that folder eclipse as a diamond shift software. This is our software. This is the eclipse id. This is the view of eclipse id. Whenever you open first this type of window will show on the eclipse id. Let us now we will see how to build a new project. If you want to build a new project, you have to go to files, new and project. This is shown here. After this into going the project, we have to select a C project and click on the next. After this, we have to select the empty project or toolchain as a cross GCC. As we have to use the cross compiler, we have to use the cross GCC. Then we have to check the debugger or released are selected or not. After that, clicking on the next. Then we have to browse the compiler path as a usr bin and the compiler prefix as we have to given in that command arm linux hyphen gnu blib. Click on the finish. Then you have to get this type of window. Here is the project explorer. Under the project explorer, you have to given the ISU2. As I have given the name of project as ISU2, it has contained the include files or include folder. Under the include folder, you have to get the 4 files. If you have not get that file, then your project is not properly built. So you have to take care that, and if it is not, then you have to repeat the process from the eclipse id. After that, for a code, we have to right click on the IS project name and go to the new and files. Name the file with the extension of .c. As we have to code in the C language, we have to give the extension as a .c and finished. After that, we will get the file like a isc2.c. This is the file. You can see that. We have to write a code on that. Here is the code. Before that, I will tell you the on the as the LM35 interfacing of the LM35 and ADC. This is the code for the LM35 and ADC. LM35 is the analog sensor. As LM35 is the analog sensor and as I said, LM35 is the analog sensor and ADC gives the digital output. And you will see the LM35 sensor has a property or a sensibility as 1 degree change in the temperature. LM35 sensor is measure the temperature from the surrounding and it will give the output as a in the millivolt or volt as per the change in the temperature. For 1 degree change in the surrounding or temperature, it will change the output at 10 millivolt for it. This is the step size for the LM35 sensor. And we all know ADC in the Beaglebone is 12-bit ADC, and ADC has the maximum reference voltage at any pin of the Beaglebone has 1.8 maximum voltage. So we have to first of all we have to determine the step size for the ADC. Here I have determined the step size for the ADC as maximum reference voltage is 1.8 and ADC is the 12-bit ADC in the Beaglebone. So we have to put the 1.8 divided by 2 raised to 12. It will give us 0. Approximately equal to 0.44 millivolt. This is the step size for the ADC. So we have to getting the correction value or correct value as per the this is the these are the step size are totally different from us both. So we have to require one factor which will equalize the all. So we have to as step size for the LM35 is 10 millivolt and the ADC is 0.44 millivolt. It will give the step size at 20 factor as 22.75 approximately. So the real value is the 22.75 times or output which we will get from the ADC is 22.75 times of the real value. It will give the calibration of LM35 and ADC. This is the required must. If you get this point, then you will get all the things for the required for the our coding. This is the code. Um, hash include stdio.h lib fnctl unsigned string error number. These header files are required for the including these header files are required for compiling the code or they are used in the code further. The defining of maxbuf is used for um, store the values anywhere. Then defining the sysfc underscore gpio underscore dir path. This path is used in the exporting GPIO pin or set direction for the GPIO pin. Further, you will see this path is a slash sys slash class slash GPIO. As per the GPIO pin have to first of all export, then we will can use that pin. If we'll not export the pin, then we will not use that pin for the further functioning. So we have to first of all export that pin. We will see there is a function for GPIO export pin and GPIO set direction. In void main you see int fd. Fd is required for the storing the path which are required, and temp value is required for the temperature value that will get from the ADC to store that value, which is digital form. So we have to assign the integer. Character buff is also used for the GPI export. Here we give the argument as a 39. 39 pin in the Beaglebone is the analog channel, which is the analog 0 channel. In the ADC there are 7 channels we can use. Further we have to use only one. Here we have required only one, so we can use the only one pin as a 39 analog ADC channel 0. Then we have to export that pin, so we have to pass the argument as a 39, and for the set direction we have to pass the argument as a 39 pin and 1 for making the input pin. In Beaglebone, if we have to make the pin input, we have to make the 1, or for output as 0. SNPrintf is used for the buff or a path where the files are present. As you know, ADC value are get in the file voltage in underscore voltage 0 underscore raw. This is the standard file where we can get the voltage of that pin. So we have to give the full path from the system to that particular file. So this path is written in the buffer using snprintf. This path is slash sys slash bus slash iio slash device slash iio uh, device 0 slash in underscore voltage 0 underscore raw. In that in underscore voltage and underscore raw, we will get the voltage for that. Then fd open read only. As per the we have to only open this file and only read. We have not required any write function, or we have not changed the value. So we can only use the only read function. If the fd gets the value less than 0, then it will print not able to read the data. Then read fd ampersand of 10. Then temperature value is equal to ATIO buff. The buff in the buff there is value stored which will get from the ADC, which is converted, so which is in the volt. So we have to, which will in the string as the buff is there. So we have to convert that string to integer. So we can use the ATIO function as buff is the string. So in the temperature value we will get the integer value. If that value is greater than 796, then it will print the temperature is above 35 degrees Celsius. As per the you have the question might that why 796. As per I previously define or discuss with you as 22.75 is the factor. So we if you multiply 35 degree to 22.75, then you will get the number as 796. So that number, as the ADC has the digital input, digital output, sorry, then you have to get that number. So we have to compare in the if condition as a that number which we will get in the integer. So we have to give there, then close FD will be closed. Then here we'll see the export function which will require for the, as per I discuss, this function is required essentially, because if you are not export the pin, then you cannot use that pin. Here is the function void GPIO underscore export unsigned int GPIO. Uh, we have to pass the parameter as the only pin. Then FD length, this is right only. Then FD is less than 0. Then we will have to print P error, print the P error. If not, then we have to uh, go to the next line, which is length is equal to SN printf buff size 0, size of buff percentage GPIO. It will get then length of the um, this length function we will use for the write to the buff. Then close FD. Then void GPIO set direction. Uh, in that function we have to set the direction. As you see error in the problem, here is a, here at the end you see three error or a problem. This is because of I have not saved the file. If I have saved the file, then it will goes, I will show you. If you have got the same problem, you got the same error where the read function or write function, then you can check whether you have saved the file or not. If we are not saving the file, then it will get error. I will show you. Here problem is zero item or zero error. Error is gone as I have saved the file. So it will get error will removed. Okay. As if anybody want the video, or if anybody want the code of LM35 interfacing with the ADC, then I will provide the in the description code file. You can get it. You can get that file from description box. Okay. Thank you.